Alright, so in this video, we're going to be dealing with negative exponents. So negative exponents are not favorable in an Algebra 2 or a pre-calc class. We always like to express our answers in positive exponents. But in a calculus class, we actually do like negative exponents. Oftentimes in a calculus class, if we have like something like 1 over x to the third power, right? If this is equal to f of x, we would actually like to write this as x to the negative third power for differentiation or integration purposes, which you will learn later on, because it's easier to integrate this. You bring this down and you do the integration, differentiate this, because you bring this down and you do the differentiation techniques. Even for integration, it's actually easier to have it as a negative exponent. But here in a pre-calculus / algebra class, we wouldn't want to do that. So let's say that we had the function f of x, which was equal to 1 over x to the third power. So let's say that I wanted to bring this up, and I wanted to write this as a negative exponent. How would I do that? Well, actually, let me go in reverse. Let me not do it this way. We'll do it this way later. So let's say that we had x to the negative third power, and I wanted to write this as a positive exponent. Well, whenever we have a negative power, the way we turn it into a positive exponent is we either bring it down or bring it up, and we make the exponent positive. In this case, we have a negative in the numerator, so we bring that down to the denominator, making it positive. So this is equivalent form is going to be equal to 1 over x to the third power. This is equivalent to this right here. Similarly, if we had g of x equal to 1 over x to the negative fifth power, what we do is we'd actually, instead of bringing it down, we'd actually take this and bring it up and make it positive. So this would just be equal to x to the fifth power, which is actually a much better looking function than this. So we'd actually express it like this in any math class, really. So this would be better even in a calculus class, because we typically like to have just the function. We don't like having rational functions necessarily in this kind of case. And even in a class like pre-calculus or algebra, we like to have positive exponents. So this would be a desirable way to write this function. So as a general rule, we would have so when dealing with negative exponents, move the part of the functions. So I'll just say move down or up, and make positive. It's kind of a general tip, general rule when dealing with these things. So let's now look at some more complicated examples that we can work with. It's important to familiarize yourself with different kinds of problems with these negative exponents. So let's say that we had f of x equals x to the negative third power over x to the negative fourth power. So here we have two negative exponents. It's kind of weird. Now, you might be used to thinking about these exponents. You might be thinking about, we have common base, so let me just subtract these two. Well, you can do that, right? You can do -3 minus -4. But let's not do that now. Let's first rewrite this as positive exponents, and then let's do the subtraction. So we can do it either way though. So this is just going to be equal to, so remember, whenever we have negative, we just bring it down or bring it up. So this is negative, so we can bring this down, but we have a negative here as well, so we can bring this one up. So it's like a cycle. So this just becomes x to the fourth power, bringing that one up, over x to the third power. Remember to make them positive. So this is an equivalent way to express it, and this is actually a better looking way, in my opinion. So this would be equal to x to the 4 minus 3, which is equal to x to the first power, which is just x. So that is what you would express it as. And remember, if we have something like x to the a times x to the b. This is just equal to x to the a plus b. The exponents don't need to be equal to each other, but the bases do. So let's look at another example. So let's say that we had h of x is equal to x to the, so it's a 2x to the third power raised to the negative second power all over x to the negative fourth power. So this one looks kind of messy, but remember we have to think about what we can do here. We have a negative exponent and that's raised to over a quantity. So we have not just like x to the third power squared, but we have another number, a coefficient we have to deal with as well. So what happens when we have this kind of a case? What happens is we can take this negative and we can distribute it to each individual term. So each individual term gets this negative 2. So this is equivalent to 2 raised to negative 2 and x raised to 3 times negative 2, which is negative 6. Just write it like that. Basically, x to the third power raised to negative 2 is just equal to x to the 3 times negative 2, which is x to the negative 6th power. So this is what we have here, and this is equivalent. The numerators are equivalent, all over x to the negative fourth power. So here we have 3 negatives, but we can always follow our rule. This is negative, bring this one down. This is negative, bring this one down as well. This is negative, bring this one up. And make them positive as well. So this is just going to be equal to, so this one's going up. This is x to the fourth power. Let's write that one first. Over 2 squared, so making the negative positive, and x to the 6th power. This is equal to, let me first simplify this. So this is just x to the fourth raised to the 4x to the 6th. We have x to the fourth and x to the 6th. We can do 4 minus 6 because whenever we have x to the a over x to the b, this is equal to x to the a minus b. But remember, if we have something like x to the a over x to the negative b, this is not just x to the a minus b. No. This would be equal to, actually, this would be equal to x to the a over x to the negative b is equal to x to the a minus negative b, which is equal to x to the a plus b. Remember that whenever we have a negative b, so whenever b is negative, we have to do the negative, and then b would be like in parentheses. So I like to write it in parentheses so I don't get confused. Some people don't like to write it in parentheses, they just immediately make it positive, which is also completely okay. So this would be what we have. This is just equal to, so 4 minus 6 is negative 2. So what happens is this wouldn't be 1 over 4x to the negative 2. This is not correct. This is not correct. In fact, whenever we do the subtraction, we just put it up. We just bring it upstairs. It's always in the numerator. So this is just going to be x to the negative 2 over 4. This is equivalent. These two are equivalent. 4 minus 6 is negative 2. We just bring it up here, and then that's over 4. But we don't like negatives in a pre-calculus and algebra classes. So this would just be 1 by 4. And then what I'm doing here is I'm taking this and I'm bringing it down, making it positive. So that's 4x squared. And that's your answer. So that's the simplified form of this horrific mess right here. Okay, so that was some examples with negative exponents. I hope you found this video helpful.